So we've already seen that when you try and integrate 1 over x from 1 to infinity, this whole thing here, for some reason, it would diverge. And then we've already looked at when you try and integrate 1 over x squared from 1 to infinity, this whole thing here will for some reason converge to one value. So this one here, it will diverge. This one here will converge. Now we're going to look at a general case of 1 over x to the power of n from 1 to infinity. So now we're going to look at the general case. So for example, 1 over x to the power of 7, what would that be? Or 1 over x to the power of negative 3. So this n here, we're going to look at a general case of when it's to the power of n. Well, if you look at this here, if you try and integrate this from 1 to infinity dx here, this thing here, you've got 1 divided by, you've got 1 divided by to the power of, well, I'm going to rewrite this bit here as x to the power of 3. So it's 1 over x to the power of 3. So you've got 1, that's this 1 here, divided by, that's this divided by here. This thing here is this thing here. Well, this thing becomes x to the power of 3. So when you try and integrate, when you try and integrate 1 over x to the power of negative 3, that's the same as you doing this, integrating it from x, well, integrating this. These two are the same. So, but then if you look at this here, if you look at x squared, let's just say y equals x squared here. If you try and integrate from 1 to infinity, from 1 all the way to infinity, you can see that the area will increase and will increase and will increase. It's not going to converge here because you can see as you integrate from 1 to infinity, as you head towards infinity, the area will get bigger and bigger and bigger. It doesn't converge. So if x squared doesn't converge, then x to the power of 3. So this is x squared here. X to the power of 3 will even be steeper. So it's hardly going to converge. So when you look at the general case, when you look at this here, 1 over x to the power of, let's say, negative 5. Well, that's the same as you integrating x to the power of 5 from 1 to infinity. Well, this is hardly going to converge. So you should have a hunch that it should diverge. But then you should have a hunch that this will diverge. If you have x to the power of if you have 1 over x to the power of 2, then this will converge. This will diverge. Well, this here will diverge. You should have a hunch that this will diverge. So visualize this thing here. When it's negative 5, visualize it as this, and then you should have a hunch that will diverge. Well, putting your hunch aside, let's just try and integrate it for the general case. So when you try and integrate this, when you try and integrate this from 1 to infinity, we're going to use our normal routine. Let's integrate it from 1 to b, and then later on we can let b head towards infinity. So our normal routine would be to integrate it from 1 to b. So let's try and integrate it from 1 to b, and then later on we can let b head towards infinity. So rewrite this as this. So we are now going to integrate this for a general case. So rewrite this as this. So now integrate this. When you integrate this, it will be 1 notch higher than whatever this thing is. So hang on. So when you integrate this, it would be this thing, whatever it may be, and then it's going to be 1 notch higher. So it will be this thing plus 1, and then you got to divide it by this. Well, integrate this. It will give you this. So now you got to put the b into the x. Remember, you got to put it into the x, not the n, because if you look at this, let's say we're trying to investigate 1 over x to the power of 7. Then in this case, n is the 7 here. N is fixed. The minute we decided to investigate 1 over x to the power of 7, then n will stay fixed, and then it is the x that's moving about. So we need to put this into the x, not the n, because the minute we start to investigate x to the power of 7, then n stays fixed. N is a constant the minute we start to investigate this thing here. Well, we've got to put this into the x here, and then that will then give us this thing here, and then put the 1 into the x here, that will then give us this thing here. So so when you integrate this, it will give you this thing here. Okay. So now now let me think. So so once you're here, this thing here, you've got this thing to the power of this thing here. Well, 1 to the power of 3, it will be 1. 1 to the power of 4, it will be 1. 1 to the power of 0, it will be 1. 1 to the power of negative 3, well, that's the same as 1 over 1 to the power of 3. That will also be 1. So this thing here will always be 1. So and then tidy this thing up. So switch these two around. Let's just switch these two around so it looks slightly neater. And let's put this behind here so it looks slightly neater. So this thing here will then become this. So now you've got same denominator, so you can merge the two together. That will then give you this thing here. So hang on. So when you integrate from 1 to b, it gives you this thing here. But now we need to let b head towards infinity. The minute we let b head towards infinity, then we can say we are actually integrating from 1 to infinity. So now let b head towards infinity. This thing here will become this. Okay, because we are, the minute we let b head towards infinity, we can say that we are integrating from 1 to infinity. And then on this side here, let b head towards infinity. So so this thing here will then become this. Okay, and then you, if you look at this here, it is b that's moving about. It is this thing that's moving about. N is really a constant. The minute we decided to investigate 1 over x to the power of 7. So n here is 7. N is the minute we start to investigate this thing here, n is a constant. So this is a constant. This is a constant. And then if you look at this, it is the b that's moving about. So we can visualize this thing here as this being a constant. This here is being a constant. 1 over this thing here. This is a constant. So we can then take the constant out, because it is the b that's moving about. It is just this thing that's moving about. We are letting b head towards infinity. So this thing here is a constant. So let's just take that out. That will then give you this. So now it really boils down to this. So so now because I want to turn this into a fraction, let's just imagine this. Let's just rewrite this thing as this thing here. Because if you think about it, here you've got negative n, which is negative n here, and then you've got a minus, that would be a positive 1. So just rewrite this thing here as a minus whatever this thing is. So just so that we can turn this, into a fraction. So rewrite this as this, and then turn into a fraction. The reason why we're turning into a fraction is because in the next video I will explain why. Because once it's in a fraction, you can see what's going on. So so we are now investigating from 1 to infinity. So when you integrate from 1 to infinity, it gives you this. In the next video, when it's a fraction, you can try and understand. You will understand what's going on. So I will continue in the next video. Just remember that we are integrating 1 to infinity. It gives us this. Once it's in a fraction, then we will have an insight into what's going on. I will continue in the next video.